question says triangles A and B are similar. Find the value of the side labeled X. Good. So this is the side labeled X. That's one. Number two, it says triangles A and B are similar. This is very important. So triangles A and B are similar. Excellent. Now, what does that mean? It means that if we look at triangle A and the distance from here to this point here is similar to this from here to here. We have so much similarities. And then if we look at this from this point here to this point there, which is 3, it's also similar to this to that. Good. Now, this takes us to the word scale factor. Beautiful. Scale factor. Now, we will also look at an addition to scale factor, which is linear. Linear scale factor. And linear has to do with straight lines. So because this is a straight line, we have a straight line from here to there. Given, and we have another straight line from here to here. So we will now employ the word linear here because it has to do with a straight line. And scale factor here refers to the amount at which this increases. We could see that this here, we have 3 of it in shape B. Okay, let's tidy up a bit. In shape B, we've got 3 of A in it. If we look at this distance, gonna circle green from here to here is 5. That means if we break this into 3 parts, that means from here to here is 5. And then from here to here is another 5. Okay. And then from here to here is another 5. Beautiful. So we've got 3 of it in there. And that's good. And if we multiply this, that means it's going to be the value here is going to be 5 times 3 will give us 15. 15 there. And that means for the other side here is going to be this side here. It's going to be what? It's going to be the same thing. It's going to be 3 times 3. So the 3 here is going to be 3 because it's increasing 3 times. So it's going to be 3. So we have from here to here, and then to here, and then to there. So that means we've got 3 there, and then we have another 3 here. Let's rub this one off. Let's remove this this black here. Good. And then we have another 3 here. 3 centimeters, and then centimeters. And we have another 3 centimeters there. So this side here should be 9 centimeters. But we're not going to solve it this way. We're going to solve it another way. Good. So we will be employing the phrase linear scale factor here. So let's just tidy up. So let's rub everything off. And then we look into the definition of the word linear scale factor. Okay, beautiful. Good. Linear scale factor. Now, linear scale factor is the ratio between the length of 2 corresponding sides. You can see the length coming up here. Length, because it has to do with linear, of 2 corresponding sides. So we have 2 sides here, 2 corresponding sides. Good. To obtain a number by which we multiply the length of one side to obtain the length of the other. So we need to obtain a number. Now, obtaining this number, we're not going to use that number to multiply one of the side. We use that number to multiply 3, we're going to get this. So that's what it says. Now, let's solve this out. So to do with this, we start with linear scale factor. Linear scale factor. So linear scale factor, we go for the big one. So we have big over small. Good. Now this one here is a big one. We can see how big it is. It's 15. And then this one here is a small one, and a small, and this one here is the big. Ah, good. So big over small. So here we have the big. The big will be 15. We take one of the sides now. We're going to take 15, divide by the small, which is 5. And this is going to give us 3. Now our linear scale factor is 3. Beautiful. Now the next step is we want to get the value of x. Okay, let's tidy up a bit. Okay, tidy up, tidy up. Good. Now our aim is to get the value of x, but we've got a scale factor. So the scale factor is the number by which you multiply the length of one side to get the other. So we could see that there's an increase, there's a scaling up. So from this smaller one, you've scaled up to this bigger one. Ah, good. So all we need to do is just multiply by 3. So we go now, we take this side here, which is 3. So here, x will be, we go to the smaller one, which is 3 centimeters, and then we'll multiply it by the scale factor. So by the linear scale factor, not by linear scale factor. So here our x will be what? 3 centimeters. And the linear scale factor, what's the linear scale factor? So we have linear scale factor here. Linear scale factor is 3. So we're going to multiply by 3. Okay, so our x here will be what? 9 centimeters. Beautiful. ENS is equal to 9 centimeters. Beautiful.